Hi, everyone. Thanks for joining us today for Oil Analysis in Action. My name is Auburn Meadows, Community and Event Manager here at AssetWatch, and I'll be your host today. Before we get started, wanted to share a few housekeeping notes with you. First, this webinar will be recorded and shared with you post-broadcast. Second, we will be answering questions live at the end of the presentation, so please drop your questions in the comments box. If we run out of time to answer your question live, an expert will reach out to you directly. I'm excited to kick things off because we're diving into one of the most valuable but often misunderstood tools in the maintenance and reliability toolkit, oil analysis. It's not just about sending samples to the lab. The way you store, handle, and manage lubricants can make or break your results and ultimately impact your ability to protect critical assets from failure. Today's presenter is someone who knows this better than most, Kyle Privet, Lubrication Program Manager here at AssetWatch. Kyle brings over 15 years of experience in maintenance and reliability. He began his career in the mining sector, working hands-on as a technician before moving up to leading entire reliability teams. Throughout his career, he has focused on lowering operation costs and increasing equipment uptime, especially for high-value assets. His work in oil analysis and failure analysis has directly resulted in major wins for the organizations he's supported, including securing OEM warranty assistance from everything from $10,000 gearboxes to $1.2 million wheel motors. Kyle is a certified lubrication specialist, holds an MLA-3 certification, and is trained in thermography, ultrasonic testing, and failure analysis. Today, he's here to help you level up your oil analysis program with simple and actionable tips that you can take back to your plant. Kyle, over to you.
Thank you, Auburn. Appreciate that there. So let's go ahead and dive right in. So we're going to be looking at oil analysis in action, avoiding your common pitfalls and protecting your equipment. So let's start off with a quick poll. Let's see where everybody is at. See if you've looked at oil reports before and how often you look at oil reports. So take a quick moment here and let's see where everybody is at. All right. So we have a decent split here. We have some people that have never looked at one before. We have quite a few people that look at them often, so that's good to see, and on occasions. Yeah, so this is a pretty good spread there. Excellent. So we're going to go through some of the basics. We will look at an oil report, see what's in one for those people that are less familiar with them. We want to see where everybody's at in their programs. We want to see what the pitfalls are of implementing a program and how we can avoid them. And what is the future of these programs? What does it look like? So starting off with some of the basics, the fundamentals. So used oil analysis is the study of the lubricating oil that has been used in a component or a system to check the health of that component or system. So we're really taking a look at our fluid properties, our wear debris, and our contamination. So the way we do that is through a variety of tests. So we look at viscosity, which is going to be your most important aspect of a lubricating oil. This is usually measured with like a capillary tube viscometer or a rotary viscometer, whether we're looking at kinematic or Saybolt viscosities. We're going to be looking at our moisture. This can be anything from a pass-fail crackle test, which you can perform on site with usually just a small hot plate, all the way up to using FTIR or even Carl Fisher for the most precise, accurate measurements of that water. We're looking at our elemental analysis, our FTR, our ICP analysis of our wear debris and of our additive packages and contaminant. So we're looking at that stuff. We're looking at our particle counts. This is usually done between pore blockage or optical particle counting being one of the most common. We can take a look at our acid number as well. So it's a common one to see, not on every report, but it is pretty common, as well as some other things like PQ index or a ferromagnetic particle concentration. So some of the things you're going to see on these reports, you're going to have your customer or site information first and foremost. That's usually up towards the top. We're going to have our lubricant, usually the manufacturer, and the product line and viscosity of what it should be. We're going to see some sample information as far as when it was sampled, when it arrived at the lab, whether the oil was changed or not, if that information's been provided. We're going to be looking at those fluid properties, once again, your viscosity, your TAN, your TBN, your oxidation and nitration, if that's on your report. Really just depends on your test slate. We're going to be looking at the elementals, your wear metals, contaminants, additives. We'll be looking at soot, fuel dilution, water, and of course our cleanliness. So usually in ISO code as well as particle counts. So let's take a look at a report here. So this is going to be sort of a basic layout, more in a vertical format or vertical and horizontal format. So it's a little hard to see on your screen. So let's take a look at individual sections. So at the top, we do have that customer information, some of that sample information, but really what we're more worried about here is what we actually see in the report. So you'll see you have a wear metals section where we can see all these various wear metals. We have our contaminant metals, our silicons, sodiums, potassium. Some of these relate to other things as well. Like a lot of times with coolants, we'll see sodium and potassium. A lot of times with dirt, we'll see silicon, although we can get silicon from multiple other sources as well. Our multi-source metals, sometimes these are additives, but oftentimes we see some of these with grease, like our lithiums and molybdenums. Those are usually more commonly seen in greases or with grease contamination, as well as our additives for that additive package to help that oil do its job. So on the next section there, we see some more of that sample information. Our customer did not provide whether they changed the oil or filters or not, but this is valuable information for your analyst. It helps them determine the next steps if they see something going wrong with your oil. So, we change the oil, but we also see a decrease in additive package. With the oil's already been changed, then we don't really need to change it again. As well as in this section, we have some of those contaminants. This being a gearbox, we didn't have anything with fuel dilution or soot. Fluid properties, once again, your viscosity being the most important. An industrial oil, 40C for your viscosity reading is very common. On engines, usually you'll see your viscosity with 100C, and that's because it's closer to that operating temperature. Part of our package, we also have the acid number that is displayed with everything. So here we can see that acid number trend. And then if your test slate has oxidation and nitration, you'll see those as well. The last section of the report is going to be holding your particle counts. So we have our ISO codes as well as our true particle counts here. We'll talk about particle counts a little bit more in the presentation. Likewise, we also see we have water by Carl Fisher on this report. So we are actually seeing the parts per million of water in this sample. And then last, we have the PQ index. Now, PQ index isn't necessarily something every lab is going to report on your basic test slate. This is slowly getting transitioned over to some other technologies. Part of our PQ index does not have a quantitative number associated with it. It's a little bit of a nebulous number, but it is getting replaced with newer technologies like FARO-Q, which do give quantitative results. So that may be something you see rolling out very shortly with a lot of labs. So what happens if you're not using our service? What happens if you get an oil report from somebody else? Well, all this information is there as well. Here we can see this is more of a vertical format, but it still has all of your sample information. It still has your wear metals. It still has your contaminants, cleanliness. It still has all of that. Likewise, we have another report. This is more of a, horizontally laid out format that spans across a couple pages, but it's still going to display everything, your wear metals, your contaminants, your additives, your cleanliness. So it really just depends on the lab format, but it should have all of that information. If it doesn't have that information, I'd be asking for it. So being able to see that report, doing oil analysis, that's a good start. But what if we want to go further? We have this oil analysis program, but what's the next steps? Well, that's where we start introducing the idea of the lubrication program. Oil analysis is part of a good lubrication program, but it's not all of the lubrication program. So the lubrication program is a concept and a culture change designed around your lubricants, your lubrication and maintenance practices from the time the lubricant arrives on site until the time it leaves the site or is completely consumed. We want to look at the life cycle of that oil. Right now, what do you believe is the most common pitfall that you encounter at your site? Let's see what everybody has to say. Contamination controls definitely up there. I would agree, we see that a lot. Lubricant storage, definitely a big concern. We have a couple people that'll drop some in the chat. That'll be interesting to see what other people have. Fluid transfer, it's good to see some people understand that that can definitely be a big issue. Excellent, excellent. So contamination control. So I like seeing that. Contamination control is one of my big things. So we'll be talking about that quite a bit. So the lubrication program, why do we need it? Well, oil analysis, while a very powerful tool, it only provides us information and guidance whenever that lubricant is in use. But it doesn't always necessarily account for our storage, handling, transportation, and other best use practices. And once again, what is the lifestyle of that oil leading up to that sample report? Let's take a look at some examples here. We have this injection molding press, our sight glass. There's no oil in that sight glass. Do we know how much oil is in there right now? We don't. We could be severely low. What happens whenever we're severely low? Well, we risk overheating that oil. We risk pulling air into the pumps. We don't get that dwell time of that oil in that reservoir. It doesn't have time to release any air bubbles, doesn't have time to let heavier particles drop to the bottom of the reservoir. So keeping that level where it needs to be is critical for the health of your, not only just your equipment, but also your oil. Then we go into this storage area. It's a little dusty in there, yeah, but we are in an enclosed space. Our oil isn't getting rained on. Our barrels are not getting rained on. Our storage tank there isn't getting rained on. And then up at the top of it, we can even see we have a desiccated breather. So as we dispense oil out of this bulk tank, now we're also removing not only particles, but moisture from that air that is entering that storage tank. It's improving the quality of our stored lubricant. So that's great to see. Then we go on to this other injection molding press. That was one I saw earlier this year. I walked up to it. There was a plug missing on the side and a cardboard funnel. That cardboard funnel was completely soaked through with oil. It had been there for quite a while. So, what type of life is that machine and that lubricant leading? We're just allowing all this contamination to go directly into that reservoir. And the particle counts really showed on this one. So it's, some simple things, making sure our levels are correct, ensuring that we do have those good desiccated breathers on our storage tanks, removing not only particles and moisture, and then making sure our reservoirs stay plugged so that way we're not allowing contaminants easy access to our reservoirs. So the lubrication program, you know, why do we need it? Well, of course, new oil isn't always clean. Your vendor is required to give you what you ordered, but there's not usually a standard for how clean it is when it's delivered. So we want to make sure that we know where it's starting at. We want to make sure that oil's clean. It's a trust but verify. Unfortunately, this year, we have been seeing more and more and more cases of the lubricant that was delivered is not the lubricant that was ordered. I'm always going to advocate that we do new oil samples at any facility. I recommend you do as well. So that way you do have that trust but verify mentality. It helps build that relationship with your supplier. One of the ones earlier this year I had, we saw 9 times higher acid in the new oil than what was supposed to be there. That supplier stepped up, replaced that oil, and improved the relationship with their customer. Great to see. And oil analysis, it is essential for one of these lubrication programs, but it's not the whole picture. Some other things that we really want to focus on for that is labeling, fittings, filtration. All of those things go into helping that lubricant be the best that it can be. It goes into helping prevent contamination. It helps prevent putting the wrong oil in the wrong asset. It goes so far for contamination control, using fittings instead of open pouring, making sure we do have that closed system and give contamination the least chance possible to affect our equipment. So, lubricant storage, lubricant handling, contamination control in your sampling practices. We just got some more examples here. I believe anybody would love to have this storage system here on the left-hand side. It's really nice. It's color coded. It's well labeled. There's filtration. There's good dispensers. It's great. Understandably, that's not always possible or not always feasible at a lot of sites. A lot of sites end up using 55-gallon drums, and there's nothing wrong with that. You just got to make sure you treat it right. Here on the right-hand side, we see treating that 55-gallon drum right. So we have these barrel adapter kits. These ones were supplied by the oil vendor, but they can be had from a variety of places. But the important thing here is it allows a desiccated breather to be added to that barrel. So once again, as we dispense and we pull air in, we are making sure that air is clean and dry. Likewise, as we go through hot and cold cycles and that barrel breathes, same type of thing. We're making sure that oil stays clean and dry. Now, you see the fittings there on the other side on the larger bung. So these allow kidney looping of that oil. In fact, usually kidney looped with the filter carts right behind it. So that way that oil can be very clean before it is used in a component. So simple things like this can go a long ways for improving the quality of your lubricant and then improving the quality and life of your assets. Compare that to the examples in the middle. Dipping a sample bottle into a used oil source. Seen it. Unfortunately, that does not give a good representative sample. Who knows what else was in that drain bucket before we got that sample? Maybe there's fuel in it, maybe there's coolant in it. This one does have a little bit of a red tinge around that label. So this would definitely turn up as a bad sample. It's going to waste time, waste resources. Or we just grab a bucket, transfer some oil. We need to put a few gallons into a gearbox somewhere. Just grab the first bucket you find. Well, what was in that bucket last? Are we going to verify that it was clean? Are we sure it was clean? Or is it just one of those, we just got to get it filled right now, just grab whatever? So paying attention to that storage, that handling, how you transport that oil matters. Once again, on your storage side of things, you know, these barrels, we see there's moisture, there's water sitting on top of these barrels. So what can we do to prevent that? You know, well, we can store them under shelters. We can tilt them. We can make sure things are covered. That's going to be the big one. Storing those barrels properly. You know, at the end of the day, do we want to make that lubricant better or worse for our facility? I believe we're all going to say we want to make sure it is better. Likewise, into our storage and handling practices more here. Proper labeling is essential to avoid accidental fluid mixing. Facility after facility I've been in, this is extremely common to see. We're using multiple lubricants across a facility. There's no labeling. Gearbox 3 is low on oil. Go grab some gear oil, throw in it. Well, what gear oil does it take? We have a new technician. They don't know. They just grab whatever gear oil they see first. Is it the right one? Is it the ISO 220? Is it the ISO 460? Well, they don't know. Labeling is very important and it's super simple to do. This was a project that I took on at a previous place, and it was adding tags up on the bulk oil reels. We were seeing a lot of issues with cross contamination, 30 weight getting filled into 10 weight hydraulics, and vice versa. So, this definitely helps out with preventing that. The newer technicians were able to look up and go, okay, hey, I accidentally grabbed the 30 weight when I need the 10 weight. Simple things. The bottom picture, we have this oil storage area. Do we know which one of these is the new oil? Do we know which one of these is the used oil? At this facility, there was no labeling. They had also told me that there had been many times where they hire a new person grabs used oil and puts into a machine because they didn't have labeling. Simple things. You know, the only way they really knew which one was used and which one was new is we look at the tote in the middle there's a red funnel on top of it. That is the only way they could distinguish which one was new and which one was used. Used oil had the red funnel on top, but new to a facility, you may not know that. So clearly labeling things. Keeping your new oil and your used oil separated is even better. If you can put some physical space between your new and used areas, it's even better. So back on the barrels, because these are such a common source of contamination. Once again, we have another barrel here, this SHC mobile product, just a lot of water and even some ice on top of here, all the way up to the rim. So what happens as that barrel cools off? Well, we start pulling that water in. We can start pulling that moisture in through those sealed bungs. It's pretty wild, but it does happen, and it can ruin a very expensive barrel of oil. I'm sure there's some of you that are using these mobile products and know how much these cost per barrel. If you have to throw out an entire 55-gallon drum, a lot of times with this synthetic oil, you can be throwing out $1,000, $1,500 just by improper storage of this barrel. So we want to try and keep that off. So again, it can be ideally inside, stored on their side with the bungs at 3 and 9, but understandably, that's not always feasible. So what are the other things we can do? There's these simple barrel covers, at a minimum, something like that. They'll at least help keep water from accumulating directly on top of it. And sometimes even just tilting that barrel just to make sure the water runs away from those bungs can be enough to really save that barrel. Still not ideal, but it's at least a preventative measure. How we transfer those fluids. Once again, we see this top one picture here. We see a bunch of fittings. They're all covered in dust. They're mixed up. They're not organized. They're not labeled. So now what happens whenever we use one of those pieces of black pipe, put it on the end of a dispensing nozzle? Well, all that dust, all that debris that's accumulated in there, plus whatever lubricant was in there last, we've just put that into a new component. Simple things that you don't think are causing a lot of harm can cause a lot of harm. It may not happen today, but it's a slow eating away of your equipment that gets you. So use sealed containers. So we have these color-coded sealed containers here. They're available through a variety of manufacturers. Those work great. They keep your lubricant sealed. They have nice spouts that close off. Everything stays sealed. You're not worried about water falling in it. You're not worried about particles getting in it. Keep it sealed. Keep it clean. Sometimes we need to do a little bit more than just a gallon or two top off. Well, now we can look at using a filter cart. Use that filter cart with your bulk oil source, whether it be a 55-gallon drum or a tote or something else. Use that filter cart to transfer the oil over. Now we're also filtering that lubricant as we're putting it in those new components. We're ensuring that we remove some of those particles before they go into our equipment. Those particles are not going to cause extra wear now. It's oftentimes we see oil exceed 18, 16, 13 on our particle counts, on our ISO codes from that new oil. We usually see it anywhere from 3 to 5 ISO codes higher than that. It is not uncommon to see a 22 or a 23 in our 4-micron slot. We also want to protect our fittings. Keep these things sealed. Keep them somewhere where they're not just accumulating dust and dirt and debris from the atmosphere. Do everything you can to prevent that from happening. So this is another slide that we see sometimes here. So the circle of despair. And a lot of places, unfortunately, this happens. It's a little tangent to our normal subject today, but we see things get missed. We see preventative tasks get missed. Those resources then can't be scheduled properly. We end up putting temporary fixes in place. Well, those temporary fixes become, unfortunately, fairly permanent, which leads to more failures, more rework. We see our maintenance personnel, their morale declines. Well, Now our work's not as good. We have to start increasing our spending. We have to have those budget constraints then because we are spending so much more money, which means we lower our standards and then we repeat that cycle. Breaking out of this cycle is extremely hard. Getting out of that reactive state of maintenance and getting into that proactive state of maintenance is extremely hard. But a lot of times, some simple contamination control is one of those things that can really help you break that cycle. May not help you tomorrow, but it'll help you 6 months from now. It'll help you a year from now. It'll help you a year and a half from now, and so on. You start breaking that cycle, you start seeing those improvements over time, and we can start focusing our resources in other areas that really need it. So, contamination. Well, what is a contaminant? We talk about contamination quite a bit so far, but what is a contaminant? Well, it's anything not designed to be in that component or system, anything not designed to be in that oil. This can be hard particles, dirt, wear debris, tools, missed parts, rags. This can be soft particles like varnish, fungus, and algae, although fungus and algae usually you see more in fuels, not so much in oils. It can be liquids, water, coolant, wrong lubricants. An oil that is not designed for that system is a contaminant. So what are some of the common consequences of these things? Water has a huge impact on our lubricants. It affects our additive packages, it reduces our load carrying capacity, it increases metal to metal contact. So it's massive what oil or water will do in an oil. Dirt, obviously dirt causes all sorts of wear. It's very hard. It can oftentimes be harder than the steel around it. We see erosion happen in hydraulic systems, especially those small particles going at high velocities around those hydraulic systems. Every time they have to squeeze through a valve or go around a tight bend, there's a chance they're going to impact the surface, eroding away that surface. Rags. Rags left in equipment it's not a common problem, but it is a problem. There's a case in particular that I'm well aware of from a coal mine in Wyoming. They lost a $500,000 engine because a rag was left in an oil filter housing that was missed by the technician, starving the engine of oil. So rags can be extremely costly if left in equipment. Biological growth, your fungus, your algae, clogs filters, causes sticky valves, things of that nature. And then the wrong viscosity oil. I mean, we can see pump cavitation if the oil's too thick, or we see increased wear if the oil's too thin. A gearbox that normally takes an ISO 680 oil, if it has a 30 weight oil in it, we're going to see a big increase. If we put an ISO 36 hydraulic oil in that, we're going to see a lot more metal to metal contact. That oil film just cannot stand up to those stresses. So, some statistics here. So, depending on your source, anywhere from 70 to 82% of premature machine failures are due to contamination. Tiny particles, 3 microns, can cut bearing life by 66%. This is according to some major bearing manufacturers. So, in some of the financial circles, heavy industry losses are around $225 billion annually from failures. Now, if we take that 70 to 82% statistic from failures due to contamination, we can safely say 157 to 184 billion dollars annually comes from contamination. Those are big numbers. And it's not a recent problem either. This has been an ongoing issue in industry for a long time. Caterpillar has been talking about contamination since at least 1931. I was able to dig up these articles and I mean, talking about grains as small as dust can cut, your expected life. dramatically. So this is not a new issue. But since we're still talking about it here, approaching 100 years later, why aren't we getting any better at it? Why are we still having to talk about it whenever it's been such a known problem? But, that's why we are talking about it, because it is still that problem. We do need to work on it. And there are technologies to be able to help with that. So why are we worried about this though? So modern components have tighter and tighter tolerances. That's why we see such a big focus on your particle counts. We can look at these valves, these electrohydraulic valves. We can see clearances between 3 and 4 microns. It's incredibly small. It's usually stated that a human with good eyesight can see down to about 40 microns. Um, and we're looking at a tenth of that size. So as we see these increased efficiencies, these increased pressures, these increased working speeds, you know, these particles start causing a lot of issues. And once again, on different style pumps like this piston pump here, we see between 1 and 25 micron clearance there at the slipper feet. So, you know, we don't want these particles getting in there and wearing out these components even faster. A lot of these things, since they are also a lot tighter tolerance than they once were, they're also a lot more expensive to replace whenever they do get worn out, whenever they do fail. And it's contamination control is no longer optional. It is vital for your equipment health. It is vital to keep that equipment alive for as long as possible to avoid that downtime in your facility. So we've been talking about these particle counts, about these ISO codes. So what are they? There's, a lot of people may not be familiar with these, especially those that have not looked at your oil reports before. So your particle counts are just that. It's how many particles are in your oil. They're usually broken up into size ranges. For the ISO code, they report in 4 micron, 6 micron, and 14 micron sizes. The amount of particles relate back to this chart. So if we have an 18, 16, 13, we have in that 4 micron slot somewhere between 1,300 and 2,500 particles in a milliliter of fluid there. So it doesn't take much at the lower ISO codes to really start increasing. And as we look through this chart, what we see is we pretty much double every code we go up. So if we take a look at the small side of the scale, from a 12, we go at 20 parts per million. To go up to a 13, we're now at 40. Up to 14, now we're at 80. And likewise, on the high side of the scale, we double. So even though we may only see a 3 ISO code increase, it doesn't mean we're 3 times as dirty. We're actually 8 times as dirty. So it really starts ramping up really quickly as we start increasing those ISO codes. So really pay attention to those. That just because we only see a 3 ISO code increase, it's actually starting to get pretty bad, especially once we start seeing those higher numbers. If we go from a 20 to a 22 or a 23, you can see on our chart here just how many more particles we have in that oil. And those particles then increase the amount of wear that we see. You may not necessarily see it on the report. You may not see your iron go from 2 part per million to 40 part per million, but you do start seeing a trend from 2 consistently to now we see 2, 4, 6, 10. We do start to see that increase over time just from those particles. So your sampling location, your tools, and your technician skill will determine the results of what you see in those oil reports. If we take good samples, we solve problems. If we take bad samples, well, we're just wasting our resources. In the data field, it's garbage in, garbage out. So we look at this sample bottle here. Is this a real issue? Or is this a phantom caused by poor sampling? What do we all think? Just take a moment, think to yourself, is this a real problem or not? Well, this sample was turned in to me, and luckily I was able to see where it came from. So at the time, I was attached to a shop and went out to the shop and started talking to the technicians, looking at what they were sampling. Here's what I found. The hydraulic sample. So I went out to the truck they were working on and started looking around. I see around this drain port fresh oil. So our technician went over and pulled a drain port sample. Well, when they did that, they got a bunch of dirt in the sample. Had that sample been turned in, now we're going to see high particle counts. We're going to see a lot of dirt. There's going to be a work order made to inspect that truck, inspect that hydraulic system, figure out where our dirt's coming from. Well, now that truck's pulled out of production. That technician or a technician is going to spend anywhere from an hour to 4 hours inspecting this hydraulic system, and they're going to report that nothing was found, all because of the way the sample was taken. Taking your samples correctly is critically important to not wasting the time of your maintenance personnel, not wasting resources. So, you know, we see other things as well. We see the sample tubing left out. We see the sample bottles sitting out. This is contamination control of your sample. We have the sample tubing that's covered in dust. We go stick that into a component, or we get it, we have it too far down in our sample bottle. What do? We contaminate that sample, or we contaminate that component. Sure, maybe that amount of dust in a 500-gallon hydraulic system, you might not think it does a whole lot, and realistically it'll probably be filtered out. But if we have that sample tubing in our sample bottle, we knock some of that dust off. It doesn't take a lot to start contaminating the sample bottle. Likewise, over here we have these Caterpillar little quick probes for pulling oil samples live off of various components. The technician was trying to be efficient, but unfortunately, they also started allowing contamination into these sample bottles because they're open, they're vented. Well, the truck they expected to come in within 15 minutes, all of a sudden couldn't get it, and now it took 12 hours for that truck to come in. These sample bottles sat out all shift, and it was interesting to watch what happened with these. As we see all this dirt, dust sitting there, just accumulating. So once again, we've already contaminated these bottles. Now, these bottles were replaced whenever that piece of equipment did finally come in for PM. We weren't going to let them use those contaminated bottles. But now we've just wasted those bottles. If they're prepaid, you could be wasting quite a few dollars in prepaid bottles. So once again, applaud the technician for trying to be efficient, but we're kind of stepping over dollars to save dimes by doing this at the same time. Be efficient where it matters, not necessarily in a place like this. But repeated issues around this made me start looking into something. So went ahead and did a little experiment. So I set up some sample bottles. I had a control, pulled a bulk sample from a reel, had a control, set these bottles out, let them sit out there at some standard intervals, went and grabbed them, brought them back to the lab, started running particle counts on them. We can see just visibly, we already have dust and dirt accumulation. This is 240 minutes. So it's quite a long time, but this is an area where they do maintenance, and unfortunately, sometimes technicians leave sample bottles open for a long time. Likewise, even at 120 minutes, we do see a lot there on that cap. So here's what we saw. Our control came in at a 22.1912. That's not great. It's a lot higher than we want to see our new oil at. So we know there's some work to do there. We have over 2.2 million 4 micron particles in that. So, a huge amount of particles. Well, even after just 15 minutes, even though we only increased in our 14 micron slot by 1, if we look at our actual particle counts, we increased by 100,000 particles in just 15 minutes. At 30 minutes, we increased by almost another 100,000 4 micron particles. You can see our larger microns here all kept increasing as expected. At the end of it all, we had over 4 million particles. We almost doubled the amount of 4 micron particles. We went 7 times or nearly 7 times in our 6 micron particles. So there's big issues with leaving those sample bottles open, letting that contamination get to the sample. I believe Caterpillar has a statistics that says 1 teaspoon of oil will raise the ISO code of a 55-gallon drum by 1, doubling the amount of particles. So big stuff. Take care of your sample bottles, take care of your sample equipment. Make sure we're not accidentally contaminating that sample, leading to false results. So, what are the chances that contaminated sample will lead to false results? It's pretty high. You know, will this, as a maintenance manager, as a facility manager, will this lead you to allocating, time and resources and manpowers to real problems or phantom problems? I think we all know the answer there. So one of my mentors over the years said this to me, and it stuck. Make the right way the easy way, and the right way will get done. Let's make sure that we have the right tools, we have the right training, we have the right everything to be able to do things the easy and right way. Make sure we have those quick connects to make hooking up filter carts easier. If we do that, they're going to get used. You know, put live sample ports on hydraulic systems to where it takes a fraction of the time to pull that sample versus doing a drop tube sample through a breather. Make it easy in the right way, and it will get done in the right way. We have the poll to throw back up now. So now, after kind of going through this, did it change how you feel about some of the common pitfalls that you see? Take a moment here. And it may not have changed much for you, or it may have opened your eyes to some things. You know, either way, we want to share this knowledge with everybody that we can to make everybody's facilities better, to make sure everybody's programs get better. So hopefully, if it is still what you suspect is the most common pitfall you experience, you recognize it. You're able to take some things back with you, even if it's just labeling. Maybe it's using filter carts to transfer that oil. Maybe it's adding desiccated breathers. Those go such a long ways for the cost of the investment. All right. So yeah, contamination controls definitely the leader there. So we got one quick case study. This came out here just last month. Some of you may be familiar with this, but don't think many people have read the report around it yet. So January 28th of this year, up in Alaska, there was a U.S. Air Force Lockheed Martin F-35A Lightning II that crashed. And it was pretty big at the time and sort of fell out of the news cycle as things do. So during the training sortie, the aircraft experienced an issue with the nose landing gear. It wouldn't retract fully. Well, they tried cycling it a little bit and it sort of got stuck. It was stuck about 17 degrees to the left, according to the wingman. Working with Lockheed Martin engineers, they decided to do some touch and goes, see if they couldn't force that wheel to recenter. Well, after the second touch and go, there was a malfunction that occurred with the weight on wheel sensor of the aircraft, registering it that it was on the ground and not in the air. Well, this caused the control scheme to change, and unfortunately, the pilot had to eject due to loss of control of the aircraft. It was a complete and total loss of the aircraft, as one can imagine. What was interesting is the findings in the report, though. So during the course of the investigation, it was found that the nose landing gear and the main landing gear had been contaminated with water. The hydraulic struts had a very high amount of water in the oil, and that water froze because it's Alaska in January. And when it froze, the struts were not fully extended. This made the aircraft register that it thought it was on the ground because the struts were collapsed a little bit. This disabled those flight controls. Well, they started tracking everything down, and they found the 55-gallon drum of hydraulic oil that was used to service the aircraft. They sampled it, and they found that nearly 33% of that barrel was water. And that was from improper storage and handling. So, and they were able to replicate this in another aircraft on the ground. So what they found was that the HACOM system, the program managers did not lock the barrels. They did not keep good records of it. And it caused a lot of issues. So we also saw that, the investigators saw that on their barrel pump, they didn't use any Teflon tape. They didn't have any desiccated breathers. So this was allowing moist air and water to get into this barrel, contaminating it. So simple things like that caused the crash of a nearly $200 million aircraft. A little bit of water getting into a barrel of oil. Water can cause major issues. Be very aware with your 55-gallon drums what you're doing and what that can do. Sure, most of us don't have $200 million pieces of equipment that we're looking after, but we can still take out $10,000 gearboxes. That's a pretty big issue at a lot of places, especially if it's an older gearbox that you don't have a replacement for or don't know a manufacturer for because the data tag's been missing for 20 years. So other things that were found during this were there was frequent manning and supervision changes. Not uncommon in a lot of our facilities. There's frequent turnover in some places. So there's never a time to be able to establish those programs and keep those programs established. It's a big takeaway from this. So anything we can do to also record our programs and make it the standard operating procedure and keep that around for everybody is also beneficial to our programs. But ultimately, a lack of oversight for the hazardous materials program and a lack of adherence to maintenance procedures were all major contributing factors to this crash. And I think that is something that we experience a lot in a lot of different industries, is that it is those lack of adherence to those maintenance practices that gets us in a lot of trouble. So, what are some of the key takeaways for you? And do you have some easy wins that you can take back to your facilities with you? Love to see those dropped in the chat. And then was able to get through this with a little bit of time to spare for questions. So if there are any questions, would love to see those, love to be able to answer those for everybody.
Thanks for sharing your expertise with us, Kyle. Such great takeaways and such a cool case study that you were able to pull together for us today to kind of bring it home. The first question that I've got for you from the chat
Mhm.
is there a reference chart per gallon of oil which shows acceptable particles per test method?
So there are some calculators online. So Machinery Lubrication Magazine actually has some really good calculators. So you can Google that one, ISO code calculator machinery lubrication, and it can actually bring up a little calculator. You can put in like what your equipment is, the type, the amount of contamination in the area, I think operating temperature. There's a few other parameters, and it can kind of give you a particle count and ISO code that you should target for that. But Generally speaking, we're looking at, your lighter fluids, your hydraulic oils, your turbine oils, things of that nature are going to be a lot tighter than, say, your gear oils where they're heavier. And a lot of that comes down to what you can filter. It's obviously a lot easier to filter a ISO 46 hydraulic oil versus an ISO 680 gear oil. Just what it is there.
That's great. Is there a right or wrong place to pull an oil sample from on a piece of equipment?
There absolutely is. There's a couple things around that. One of those being avoid drain port samples if at all possible. Sometimes it is unavoidable, but trying to get that representative sample, and I'm going to stress that representative sample. We don't talk about that portion of the oil sample enough, but you have to end up draining quite a bit of oil to get to that representative oil sample. So we want to avoid that. A lot of the danger with those drain port samples is we see increased wear metals, we see increased particles, we see increased water, and it's not actually representative of what's in that system. And that comes down to what is the purpose of a reservoir. And one of those purposes is to let heavier sediment and debris and water separate from the oil and sit on the bottom where it's not causing any problems. Well, if we sample that, now we're getting bad results. Garbage in, garbage out. Likewise, on a circulating system, we want to be wary of where we pull that live sample from. We don't want to pull that sample after a filter because then we just scrub out the wear data that we're trying to track and trend. We want to take it from before that filter. Somewhere between the pump and the filter is where we want to pull that live sample from. So that way we know what we have actually worn, what is actually starting to feed into those pumps. So yes, there is absolutely right and wrong places to pull those samples from.
What should teams be looking for in their oil analysis reports? What are the key red flags?
So your lab is going to have some alert indicators that they may flag with a color. Those are good to look at if you're fairly new to this. Some of those can change based off of the data set the lab is using. So really, we're looking for what becomes, sort of not normal. If we see a gearbox that trends at 2, 4, 6, 8 on our iron, and then all of a sudden we go from that linear wear rate and we start seeing it trend up. We go from 10 to 14 to 18 to 24 to 30. We start seeing it increase, that wear rate starts increasing. That's a big red flag. We might still be okay for that amount of wear in a gearbox, but we are seeing that wear increasing. Why are we seeing that wear increase in a faster way? Likewise, if we see, our particle counts are staying fairly consistent, and then all of a sudden we see it go up 1 or 2 ISO codes. Why is that? Let's inspect that equipment. Let's see if there's something that we can go back to that's easy. Did we leave a cap off? Is the breather damaged? Things of that nature. So you really want to pay attention to that trend. One oil report will give you useful information, but one of the most powerful parts of that oil analysis is that trend and going from that normal state to that abnormal state and being able to pick up on that early so that way you can act on it before the damage is too severe.
That's great, Kyle. For teams just getting started with oil analysis, what do you recommend they focus on first?
Really the basics. And I know that's kind of a go-to answer for a lot of things, but we really do want to focus on the basics. We want to make sure that we know how to take a good sample. We want to make sure that we are using new sample tubing with every sample. We want to make sure we're using the appropriate, vacuum pump. We're using something something like these little vacuum pumps here and not a giant syringe that we're cleaning out with soap and water every time we pull a sample. We want to, uh, you know, make sure we're pulling it from the right area. If we're doing a drop tube sample, we want to make sure that that piece of sample tubing, is, in our reservoir in, somewhere within, the half to third there. We don't want to have it all the way on the bottom where we're also pulling up that sediment and debris off the bottom, and we don't want to pull it off the top where we have a lot of foam and it's not a representative area of that reservoir either. So really focusing on the basics of how to take that sample so that way you get the best representative sample possible.
That's great advice. We have some really incredible questions in the chat, but we probably have time for just one more. What's one simple change a plant could make today to improve their lubrication program?
So I've actually got two answers for this one, not just one. So first and foremost, labeling. We touched on it quite a bit earlier there, but labeling goes such a long ways to helping prevent cross-contamination and putting the wrong lubricant in the wrong asset. So it's, can be anything from an engraved aluminum tag to a piece of tape with Sharpie on it saying what goes in there, or even just writing with a Sharpie directly on the asset saying use ISO 320 or whatever your lubricant is. It goes such a long ways for preventing that cross-contamination. The second one is do not underestimate the humble little filter cart. They can provide so much value in not only your lubricant health, but your component health as well. A lot of gearbox systems obviously don't have filtration on them. So how are we supposed to remove those particles? Are we just going to change that oil every time it gets dirty? Or do we want to save that oil, prolong that oil's life, and prolong that component life with just the humble little filter cart? So don't underestimate that little thing. Use it. Keep it working. Don't use it for half a day and then throw it in the corner until next quarter. Use it every day on something.
That's awesome. Well, I think that's all we have time for today. Thanks everybody for joining us. And huge thank you to you, Kyle, for sharing your expertise with us. I hope everybody is walking away with practical tips to strengthen their lubrication practices and avoid some of these common pitfalls. If you're curious about how AssetWatch can support your maintenance strategy, we'd be happy to set up a personalized demo for you. You can get started at assetwatch.com. Thanks again for joining, and thanks again, Kyle. We'll see you
Thank
next
you,
time.
everyone.